Just like to introduce myself and my partner here, Matt. So we're from Fortis Alberta. Our slideshow is on designing for optimization, exploring automation. Myself, Daniel Plantinga, have been with the same company for 22 years, being Fortis Alberta, and I'm a senior designer looking after our design teams.
Yeah, so I'm Matt Reid. I've been in the industry for about 15 years now. Fortis Alberta just the last year and a half. I'm a senior engineer with our standards department there.
So this is an agenda, what we're planning to talk about today. So just a little bit more about who we are. We are currently in our implementation of AUD, planning to go live here in early 2026. So just talking about the last year of getting things up and running. I'm going to focus a little bit on optimization. I think one thing that Al mentioned there was affordability, so really focusing on optimization and getting that ROI out of the product and our workflow. The use of artificial intelligence, which has really been on the forefront recently as well. And then finally, our wish list and questions from the audience.
Yeah, so before we deep dive into AUD, just a quick background on Fortis Alberta, who we are, what kind of challenges do we face specifically as a utility. So Fortis Alberta is one of 4 distribution facility owners in the province of Alberta. Alberta is on the west side of Canada, right next to British Columbia. We provide power to more than 600,000 commercial industrial sites. We own and operate 131,000 kilometers of power line. A little fun fact is that's 3 times the circumference of the Earth. So we have a lot of overhead. We have a lot of rural. That's kind of our bread and butter. So we operate in more than 240 communities, employ over 1,300 Albertans, and those Albertans are split between Calgary Flames fans and Edmonton Oilers fans. So that's the big divide in our province. Some specific things about the terrain and soil types that we have in the province. The very same Rocky Mountains you see out your windows here in Colorado, we've got the exact same ones up in Alberta on the southwest corner of the province. Towards the east side and central, it's a lot more flat prairie land. We've got multiple wind loading zones, which is especially important for us with all of our rural and overhead. For soil conditions, we've got really rocky soil, which is hard to dig into. We've got sloughs covering about 20% of the province. So all of that is a way to say that we've got all the terrains you can think of and all the soil types you can think of. It's very varied within the province. The temperatures, even though we're one of the sunniest places in North America, in some parts of our province, can reach minus 40 degrees Celsius, and I believe that's also minus 40 degrees Fahrenheit. And then just on the very bottom picture you guys can see on the screen there, that was actually from a storm just last week. Even though it looks like it's snow on the ground there, that's golf ball sized hail that we had just south of Calgary. And so it absolutely tore apart a bunch of wood distribution poles, transmission lattice towers. It had a huge impact on our system. So just an example of something that can happen in August in Alberta.
So just a little bit more about us. So we are underneath the Fortis Inc. umbrella, part of the Fortis family, headquartered in St. John's, Newfoundland. So we have 10 subset or sister companies throughout Canada, the States, and the Caribbean. I don't know if there's any other Fortis folks here. Is there? Oh yes, there's our sister company there from UNS, I believe, right, from Arizona. And so, yeah, we have about 9,800 employees, about 3.5 million customers, electrical and gas, about 73 billion in assets, and the majority of that is regulated entities or assets in the transmission and distribution side of things.
Okay, so just a background of where we're starting from. This is just an overview of the current products that we use. So for our GIS and drafting, we have products by Hexagon called G Technology and GNet Viewer, respectively. Our customer management system is called CRM. We use SAP as our enterprise management system for material ordering, et cetera. And when it comes to our engineering calculations, they're predominantly done in-house. We do a lot of VBA programming, Excel-based tools, and there's a couple .NET tools as well that we use. Okay, so what's wrong with our existing systems? This whole project that we're doing kind of started with the end of life of our GIS system. So Hexagon no longer supports the product or the version of the product that we use. So that's driven a need to replace our GIS system, and while we're doing that, we decided we should also do some of our calculation tools, including AUD as well. So is there anything else wrong with that GIS system? Yeah, it was probably time to change it anyways. It's kind of non-intuitive. The menus are kind of clunky. Honestly, when I first opened it a year ago when I joined the company, I thought it was like a Minesweeper was going to pop up or something like that. That's kind of how the menus look. So yeah, it's super weird. The designs are susceptible to typos and mistakes. Lots of manual input required, no integration to the other systems. So for that reason, we decided to choose Esri UN as our new GIS system. Lots of advantages with Esri UN. It's going to integrate with all the other systems, including AUD, including SAP, and hopefully there's going to be a lot less rework involved, or that's our hope at least.
So we have a lot of other changes going on within the company right now, and looking for the integrations with those. So we visualize this as a house. So currently right now our data migration project, so going from G technology to Esri UN, our cutover is mid-March of 2026. Esri UN itself, mapping that out and getting that up and rolling. We just integrated a new vegetation management system work studio, a bunch of other integration projects, which include SAP, EPOC, which is our field GIS and work management system, Siami and Doble on the engineering side in our planning department. Lots of analytics and reporting that's always required to see what's going on within the company. A process adoption project, so this is more on the employee side and getting people engaged and knowing what's happening within that transition, which is very important. And finally, my favorite part of the house, which is the garage, which is where our AUD project and our changes in design are happening. So when I think about building a house as well, I've kind of thought about that as well throughout the last year with our AUD implementation. And so just a few points on that. The one really thing I noticed, the conundrum of choice, right? So AUD is a very flexible tool. Everybody uses it a little bit differently, and I was just amazed about how many decisions to make, right? So for example, stylization. What do you want things to look like? Your symbology. Us going to a CAD system, we didn't have a CAD library before. So kind of like building a house, your color palette, what kind of floors are you going to have? Well, no, we might have a dog. Okay, well, we might have to have hard floor and art carpets, right? Maybe we want to have an addition in the future, right? So all those considerations has really been a lot of effort to get that up and running. One thing that we really appreciated was best practices, and so this was from SBS and their vendors, right? This is what others have done before, suggestions within that realm. Another one, and a big shout out to Ray and Shannon from Queensland Energy. So we've met with them several times. They're stationed headquarters Brisbane, Australia. We really felt that they were similar in regards to their practice of engineering and the codes that are required in Australia versus Canada. Because we did feel like the Canadian and US codes were quite a bit different. And also, some of the cool things that they've done within the tool. And their service area is quite extensive like ours, a lot of rural area, a lot of overhead, which is similar to our service territory. Lastly, just the importance of blueprints. So our blueprint architecture documents with SBS, our roadmap and our house print itself within the company and the different tools that we're planning to do and what that future looks like for us, going forwards the next 5 years, and then just what the market and what the industry is doing as well, just to make sure that we capture and look at everything and nothing is missed.
Okay, I'm glad Dan mentioned the difference between Canadian and US code. That kind of leads me into the next, what makes us different. So this is just one specific calculation that I feel like we've talked a lot about and had some good conversations already even this week with folks at SBS. So it's regarding nonlinear calculations. So the CSA code, or Canadian Electrical Code, in 2015 introduced this clause saying, the method of analysis for structures shall be the nonlinear method, including stability and buckling checks. Cool, what does that actually mean? Before I explain that, let's maybe get into what's a linear calculation, because then you can see the difference a little bit. So taking us all back to school here a little bit. So linear analysis, if we just have a straight pole, it's considered to be totally rigid. We're going to put a tension on it. What kind of calculation can you do with just a tension on a straight pole? We want to find out if it's going to break at ground line, for example. So we're going to do a moment. A moment is a force times a distance. We know where the force is. The distance is the distance above ground. Easy peasy. What are we comparing that to? We compare it to the maximum moment that can take. You can calculate that pretty easily with just a couple parameters. We got fiber stress limit, which is determined just by the species of the pole and the circumference. So very simply, check what my moment is. Does it exceed the maximum moment? It breaks. That's an example, a super simple example of what I would consider a linear calculation. But we're probably going to guide that pole. We're not going to have a tensioned dead end. So if we guide that pole, what does linear do then? It says that the horizontal tensions are going to completely cancel each other out because that guy is attached to an anchor to the ground. We've got a theta, an angle there. That's going to translate into a vertical force, vertical downwards force. Same kind of thing. You can use simple equations. Euler's buckling equation would be the one that we would use here, just to determine whether that downward force exceeds the maximum force that pole can withstand before it becomes unstable. So this is a very simplified way to do it. You can do I've seen 40-minute presentations on nonlinear calculations. So that's my disclaimer here, is that this is all very simplified. Okay, so now let's get into actual nonlinear analysis. So what's different about it? And keep in mind, as I'm showing you this is all done through our VBA coding in Excel. There's third-party tools that do this as well. You can have things like SpydaCalc or PLS CAD that do these calculations. But for us, it's all done with in-house engineering tools. So the first thing that we would do is we would divide that pole into different sections. So you have points in 3D space that are the nodes, and those nodes are connected by what we call members, which is just the length of the pole. So now you have those members, you assign them 3 properties. So they get a modulus of elasticity, as defined by the species, a moment of inertia, which is determined by the shape, and a cross-sectional area, because that cross-sectional area is generally going to change with these tapered poles. So what do we do with all that information? For each member, remember that's only part of a pole, it's going to get a stiffness matrix. For us, that's a 12 by 12 matrix per member. Then we take all of those member matrices, conglomerate them into a giant matrix, and call that the stiffness matrix K. From there, we're applying something called spring theory, which you probably haven't seen since university, which just says that force equals a displacement times your K, that's stiffness. Well, we know what our forces are, we know what the K is, so what are we solving for now? We can solve for a displacement vector. So now we can see how each of those nodes displaces. So that's what you see on the right-hand side of the screen there. Now instead of a perfectly rigid straight pole, you've got a pole that has bend to it. Are we done at that point? Not quite. This is an iterative process, so now all my forces have changed. If you imagine that a transformer was at the top of that pole, its center of gravity is no longer right over the center of the pole or just offset, now it's way out there. So it has a completely different effect. So you run these calculations over and over again until you hit kind of an equilibrium point. Usually for us it takes about 5 or 6 iterations. So this is what we're looking to calculate with an AUD. We've had these conversations. The matrix math is apparently very difficult to do in AUD. It's thousands and thousands of small calculations, which is what makes this difficult. So if anyone else has any good advice on how we can go forward with this, like I said, we've had some good starts of conversations that I'm looking to continue this week, but that's just an example of the calculation that we do as required by Canadian code.
Thanks, Matt. So just kind of how our design process today and the tools that we currently use in-house. So the majority of our stuff is surveyed, so we use external surveyors for larger projects. We also have several Trimble units with field staff that survey our designs. Usually this comes in as CSV files, so a point, Latin long, elevation, and then a description. So whether that's a new pole, existing pole, maybe there's a crossing of a pipeline or a road, things that we do for clearance. Those are all put into the spreadsheet. We do have an internal tool that we call GPS line design. What this does is this formats that information for us so that we can use it in our current tool systems. Those tool systems being our automated line design. So this is our internal tool. I don't know if AUD stole it. We've had it for like 30 years. But anyways, so we have that tool there. What it does is it provides all those calculations for us, including nonlinear calculations, and does a 2D profile for us. So this profile will show visually if a pole fails, it turns red. Clearance checks as well. It checks several different points or survey points along there for clearance requirements, as we do have different requirements throughout the span itself. And then it also spits out for us our construction prints, so containing the span lengths, the CUs, similar to what you would see in AUD. Our SAP, there's no integration, so a lot of our stuff is manually inputted, material, things of that nature, especially in the smaller projects. SAP is also our EAM system, and where we create work orders and charge time and things like that. On the right there, you can see some additional tools that we use. So these are our internal Excel sheets, our clearance data sheet, detailed structural analysis. So this does those same nonlinear calculations, but on a pole-to-pole basis for more complicated situations. Transformer load calculator, we do bring in customer load, so we can pick a transformer. It pulls all those services off that, runs some calculations and estimations to determine if the transformer is overloaded. It also has voltage drop within there, and also on an individual service. So pull on an individual service, somebody's going to add load to that, maybe it's a hot tub or air conditioner. Then we can determine if additional changes need to be made on our side, or if it's an upgrade of their breaker, to determine whether our stuff is adequate or if they have to upgrade their secondaries.
Okay, just time for the interactive part of what we're doing here. So we're going to ask a question here. What level of calculations do you use? And this is coming a lot of what I just presented. We're curious what kind of tools you all use for engineering. Is everything done within AUD? Are you still keeping some of your internal calculators? And to what extent? So if everyone can go and... So we're just going to do a Slido here. So you'll have a QR code on the screen that you can try to use. And if you can't get into that, just go to slido.com and put in the little code there. And so then here's the question you'll get. So what systems are you using to complete structural integrity calculations? So is it done entirely within AUD? Do you still use some internal calculators as well? Do you use AUD in a third-party calculation tool like SpiderCalc? Or calculations? What are you talking about? We have to do calculations? I hope that stays at 0%, but...
Awesome. So thanks for the response there. Looks like we've had about, well, there's a few more just jumping in there. So majority of us, including ourselves, Excel is really the way to go, sounds like. Third-party tools at about a third. What calculations? A little surprised, 14% there. So if you guys need some help, Matt's really good at calculations. And also those ones that are 7%, really curious to see how you guys incorporate all your calculations in AUD. So thanks for your participation. So this is our plan going forwards with our implementation to AUD. We are planning to start rolling out to the company here in early 2026. We will also be using survey data, looking at different ways of maybe importing that information, how we do that. That information would be going into AUD. From there, our integration is to the UDH system that we can integrate with our Esri UN, which is going live in March. So being able to pull our GIS information into AUD, bring in our survey information on that, and create our design. Also the ability through Playback Manager to then have that information go back into Esri UN. Also integration with SAP, and we found some pretty helpful tools for designers with that integration as well, because that's where a lot of our information is stored in regards to CUs and material. And then finally from there, spitting out our prints to provide to our construction staff. One area that we still are looking at and discussing is what do we do with these nonlinear calculations? And so part of our methodology at Fortis and our designers is to make it easy, right? And so not really looking for users to be in a third-party calculator. We've traditionally have gone by using our internal tools, and we know how the calculations and math work. And so we still have automated line design, and so we will still have information export into ALD. This is actually currently wrong because it's only a one-way currently. So a designer would complete their design, push it to ALD, and ALD would just do the nonlinear. So it would tell you if the poles fail or not. If it fails, the user would have to go back into AUD, make the changes, and rerun it again. So not optimal, but it's where we're at right now.
Okay, so as you can tell from what we've been talking about, we're changing our GIS system, we're changing our design tools, we're getting rid of them altogether. We wanted to make sure that something kind of stayed put, and for us, that's been the existing compatible units. The point of this slide is just to showcase the flexibility of the tool and show that regardless of what your compatible units are, you should be able to input them into the model sheets and be able to keep what you have existing. This is just a quick example. This is our 2525 three-phase cluster mount bank. For us, that compatible unit also includes fuses, but we want the transformer and the fuses to be two completely different features in AUD. They're going to be different features in our Esri UN. We want them to pass information individually to each other. So through manipulation of the model sheets with the help of our SBS team, including Brent and Jessica and Jeff, they've really walked us through that, and we've been able to have success and manage to keep our CUs exactly the same, so that hopefully our staff feels like they're still experts at what they do and they don't have to learn everything from scratch. Just a quick shot of where we are now. So as Dan mentioned, we're still in the process. We haven't rolled it out en masse or anything like that. We just had over-the-shoulder testing on site last week. These are just some of the things that we're still working on. We're still ironing out our 3D models, ways to optimize certain commands, workflows. We're just getting into the underground. We prioritized our overhead since we're so overhead and rural. We really prioritized that. And we're still setting up our EAM and GIS integrations as well.
So just wanted to focus a little bit on optimization, and that coincides with affordability. So finding ways to simplify and assist things. So really finding at the end of the day, how can we improve our workflows, the tools that we use to produce for our customers? So doing things that are more affordable, doing things that have quicker timelines. So throughout this last year, definitely from going where we were to where we want to be in the near future here is just optimization through software like AUD. Also using Esri UN and AutoCAD is going to be a big win for us. The automation side of things as well, so that repetitive work that we continue to do, and I'll talk a little bit more about that as well. And then really the flow of data, right? And so I think a lot of utilities and ourselves, we have a lot of data, but it's what we do with that data, right? Is it consistent or is it in multiple systems? Does the right person have access to that data? Can we manipulate that data? Is it the right data, right? And so really looking at that as well. So some optimization that we found. So currently right now using our current drafting tool, which is a read-only GIS, which we have red lines upon it. We were creating several prints throughout the process and starting from scratch. So an estimator quoting print, and then it would go to design. You'd have a survey print, and then you'd create another print for maybe review, then your construction print, and then you'd get information back on your as-builts. So really utilizing a file that goes through this process, one file only. The ability to change layers and ports is going to be huge for us, setting up templates to automate that as well. Another one, we have tons of different layers and overlays. So even though we're going to Esri UN, we have had a working model of maps. We call them E-maps, but like ArcGIS maps, bringing that information in. So we currently do have a tool that we overlay our design in. It does calculations for us and spits out a report to say, here's the conditions that your poles or your assets are in. So you have to be aware of this environmental concern. You're in this wind loading area. You have to be concerned about some other things on there, right? So just the awareness using those layers. Looking to use some of that functionality with intelligent layers within AUD as well. One for sure is our wind loading areas. So we do have 4 different wind loading areas in our service territory. And instead of a user having to pick that or remember to select it, having the program itself know that and use it for the calculations. Also, the import and export of information is huge for us. So bringing in our GIS information, being able to see it visually, compare it to our survey to update information that's out there. Also exporting information as well to order material through SAP automatically, the playback manager. One that we just had recently here, designer who hasn't seen AUD yet was, can I find out about the status of material, right? We're always worried about, is the material even available? Is it a long lead time? Is it a purchase order item? And so having the ability to just do your design, send that information to SAP and have it send back the status of that material is going to be huge for us, right? So that might be a change of the scope of work. It might be a communication back to the customer to say, hey, you know what, we're doing our best, but this is going to take 3-4 months. We're waiting for this material on your project.
Yeah, another optimization for us has just been having 3D at our disposal. So we survey basically everything at our company. We survey all of our Z values, but our idea of visualization to this point has just been 2D projections within our VB coding or our VBA coding in Excel. So now that we can actually see things in 3D and we have these types of models, it makes conversations with customers easier. Like they might not have the same kind of technical knowledge. If you can show them a 3D rendering of exactly what it's going to look like, then that makes that conversation go a little bit easier. Or even for new designers, if they don't know how one CU looks with another CU or something like that, if you can put those together, they both get displayed on the same pole. You can check all your clearances and make sure that it actually works out the way you think it's going to work out. So that's a huge optimization for us. As we've mentioned before, our current process has a lot of repetitive tasks, rework, manual entry. So we're looking to remove a lot of these types of wasted efforts and everything like that. So we're using AUD workflows and Lisp programs to reduce the amount of steps and clicks. So just some examples. Last week at our OTS, we were looking at workflows for a bunch of our multi-pole structures, platform substations, H-frames, things like that. So we're looking to implement those types of things. We've done a lot of AutoCAD Lisps for things like survey point entry. We're actually going to do a demo on that just towards the end of this presentation. And we've done some optimizations on existing commands within AUD, the AUD profile. We've also enhanced that ourselves just to actually show the clearances. So that'll also be part of our demo later on. The rule engine within AUD. So we're looking to set up the rule engine with AUD to automatically determine the typical CUs, pole classes, span lengths, pole leveling. This is an enhancement for us just because it's making sure that everything that a designer can put into AUD is actually designed to our standards. And that's the way the rule engine was meant to be. And the last one there is just predefined CUs. It just takes away the effects of what we call fat finger syndrome, which is where people just, they meant to put a 2, they put a 1, it happens. But if the CUs are all predefined, even if they mistype something, you're still picking from a list. So you're not going to be as affected by kind of those random little mistakes that you might be able to make.
So this slide's similar to what I discussed before, just in regards to the integration, which is huge for us. So that integrating of information from AUD to SAP, which are EAM system. In the next few years, it'll also be our CAMS system, so bringing that information in and out. So whether that's customer information or load, having the updated latest CUs and material to bring that in back and forth. Our Esri UN integration, so not doing that manual drafting as mentioned. Seeing where this up and updating our existing infrastructure based off of what we see in the field, and then just the internal AUD integration as well, right? So just that one-click process, you put in a line, it's doing those calculations for you, it's creating that material. It's just a huge win for us. And like Matt said, that fat finger syndrome, I think it's a public service announcement, but it's going to be huge for us just in regards to eliminating those checks and not having to check stuff as much just for those simple errors that it's just human nature to have. Just on the opposite side of optimization and automation, and on the change management side. So this is one concern. I know most of us are probably technical in the room, but there's always a fear of different things when new processes or new tools come along. So just kind of curious on everybody's take on that as well, those that have gone before us to implement, and how you've overcome some of those fears or just acknowledged them as well. So I know one for myself, just the loss of know-how, right? So creating button pushers, right? You know, creating robot employees that just push a button. They don't really know what's happening in the background. You know, they don't know if it's missing something or if there's an error in the program itself. Just not really knowing it and having those conversations maybe with other departments or construction crew, other engineers, because they're just pushing a button. Other ones, you know, concern over job security, right? So we talk about AI, how it's going to change the industry. Maybe making things more effective where, you know, that used to be manual labor. You know, something new, right, coming in there. So you might have done this role before, but this tool is going to change how you do work, right? And so there's always those concerns and fears. The last, and this is more on the entire project itself, adoption and progress. And so you can have the greatest tool in the world, but it's only as good as those that adopt it, right? And so we're a little bit different because we have no back option, I would say, because we're going to Esri UN as well. And so limitation on people going and doing things the old way. But, you know, the acknowledgement from management as well of it's going to take some time, right? So production is going to be less, you know, we realize throughout the next year, not shoving it down people's throats, but being there to support folks, whether it's through training, peer-to-peer help. I know there's presentations last year of departments that help with that as well, and documentation, OneNotes. And so just supporting those staff and realizing that we're all in it together and supporting one another within that journey.
All right, one more question. Pull out your phones, get back on the Slido. QR code's back up there again. I promise we're almost done. I think my stomach's about to growl into this microphone. So this question is, what have been roadblocks or concerns you've had when you're rolling out AUD to the company? So this one, just enter any kind of specific concerns you've had. It'll just pop up on the map.
It is plural as well, so I mean, more than one answer, if you have more than one, is definitely acceptable as well. So. Yeah, so I think the question was, are you keeping your costing in your existing tool like SAP, or are you going to integrate it into AUD? Currently, no, we're going to keep it where it belongs, which would be SAP. I'd love to bring it in maybe as acknowledgement or, you know, high level, but part of that blueprint that we have as well is really focusing on using the right tool for the right job, and we've indicated that, you know, SAP and our costing tool is where it belongs currently.
And AUD is not a costing tool, it provides the information to do accurate costing and contracting.
Yes, we've heard that. Yes. Yeah. Yes. As Pat mentioned, AUD is not a costing tool. We've had those conversations. I'm sure some of you has as well. We'd love to have everything in AUD, but no, it's not a costing tool. Right. Yeah. Yeah. So not to say that we won't have the capability to see costing in it, but that information where it lies won't be from AUD information. It'll be coming from SAP.
So your SAP system, your Mac system, or whatever cost the system generates report, we can bring that report, down on the web, SharePoint. We can transfer that thing into AUD and bring it up to the I heard one we said enough, and then you come back, here's what the estimated cost is, then you approve your approval portion. If it's between X and Y, I can approve it, above Y, somebody's smart.
All right, so we got a pretty good response in this one as well. I see there's a couple of people adding a few more here, but really the overall adoption process looks like the winner here, right? So really understanding that it takes time to adopt to something new. Experience, that's one for us as well. CAD is new within our company to use. Lots of good things and concerns to be aware of, so really appreciate this. So one thing that was mentioned in the corporate overview that Elle had there as well is talking about artificial intelligence. And I think that's a buzzword that everybody's been hearing about. The progression of AI has been enormous in the last few years, I think above anybody's expectations. And so it's more than just a buzzword. And so just want to briefly talk about it and how we've used it in the last year, how to utilize it as a tool. And it's not something new. If you look at AI, it's been around since the 1950s. It's just, we're at a point now that we have computing power to do some of these things, right? And so I'm always blown away about the latest AI thing and what it is capable to do, so. So I know for me, throughout this last year, is starting to use AI more for daily tasks, using it in my day-to-day. Originally, maybe the first time I came across AI, maybe 2 or 3 years ago, it was just something fun to use to create children's stories, right? So you tell your kids, tell me what you want a story about tonight, right? You plug it in, tells you a story. It was pretty creative, pretty fun. But now just using it for recapping meetings, to understand things, also for creativity and brainstorming has been quite useful. Certain things to use AI effectively. I know people really love it, or they're like, I've used it, it's garbage. So what I found is it's not always going to give you the right answer right away because it doesn't know what answer you're looking for. And so really setting up those prompts, saying what you want it to be, right? And so often it'll say, you're a prompt engineer and you're an expert in utility design. Not only that, but familiar with Canadian code and working in the province of Alberta, right? So I don't want miscellaneous answers over here that don't really apply to me. I'm telling it exactly what I want it to do. And then also tell me how you got to that answer, right? And so give me a list of the reasons of why you came to that answer. Maybe have it on a point system. Tell me the pros and cons, right? And so really flesh it out. So it's not just giving you an answer, but it's really broadening that scope of work and that brainstorming for you. Just things also to avoid with AI. AI is not a replacement, right? So it is a tool, right? So be careful, the responses, right? Don't always take it as gospel. Also acknowledge that, you are sending your data somewhere else, so you can opt out of the data modeling for the language models, how it learns. But, don't use personal information in there, corporate information that you don't want to release to the public, that sort of thing. So, but yeah, AI is huge. So just one story, we do have a super user and we do have an AI group within the company of those that are interested. And so our IT guy, Rod, had several stories. One I always find fascinating was 2 years ago, Thanksgiving, his mom wasn't feeling well. She's a retired nurse. And he said, Mom, just here, use my phone. I'll put it on speaker mode. Just talk to it. Maybe we can diagnose why you're feeling sick and feeling down. right? And so she talked to it for about 40 minutes. She's obviously in the field. He used a prompt of, you're an emergency professional diagnosing a patient. And it came to the response of, I believe you had a heart attack. She said, that's crazy. Next day she went to the ER. It took about 2 or 3 days, but she had a certain type of heart attack that was really hard to diagnose. So just the power of it. It's not a replacement, obviously, for medical advice, but giving you those, things that maybe you haven't thought of, even those that are in the field. There is several different products of AI. I found there's different uses, and some are good or better than others. Microsoft Copilot, which probably most of you have internally using Windows, has been great for meeting recaps, so those to-do lists, recordings of it, the ability to search back on meetings and who was supposed to do this and when, so really having those more effective meetings because it's being capped. Internal research as well, so within Microsoft Copilot there's a web side of things and a work side of things, so using the work just looks within your infrastructure of your files, your SharePoint, your emails. So being able to search through your emails and say, hey, I remember this a little bit, it was this date. I find it way more effective than some of the filtering and search capabilities and some of the tools. And also maybe some stuff that you aren't aware. So if you're making a PowerPoint, search within the company files, pull out this information about this, right? And also leads you to maybe others within the company that are working on something similar that you can connect with. ChatGPT, really useful for how-to support. So how does this work? If you're, putting in a manual, you can summarize stuff. I found it really useful. Same thing, personal. Doing mechanical work, for example, talking to it for a while. May take a while, but you give it the time, it starts to realize what you're looking for and gives you better answers. Also coding, and then we'll show that in our demo that we've used this year for creating automation within AUD and using some of that coding within the AutoCAD. Google Notebook LM is relatively new. If you guys are familiar with it, it's really great at breaking down concepts. Another fun one, and we talked about, I think you guys, Department of Transportation, we have something similar. The province came out with a new 300 documents traffic accommodation plan that we have to follow. Instead of reading the 300 pages, plop it in, created me a podcast. So it's got 2 speakers, dives through the main concepts and brings out the stuff that's important. And there's even beta versions where you can call in as a guest or a caller and ask questions to it as well. So quite intuitive, a different way to digest information. And the last one here, I always like music and being creative and whatnot, and so this is one Suno that I personally use all the time. It's to create songs. Wrote a Christmas album for my kids here this year. I've also created some advertising and internal stuff for promoting AUD in the project as well. So this is one example. AUD, AUD. If you want to listen to the rest of the song or you want me to sign the album, I definitely can. So, we just have one more question here, a final question. I'll just put it up here. So if you still have the Slido open on your device, I'll start that here for you. So just curious on your interactions with AI. So how are you personally currently interacting with AI? So, me and AI are like 2 peas in a pod. I occasionally use it. What is AI, right? And so just kind of getting a feel of, where's everybody's level with interacting with AI. So I'll just give you guys a minute. We're just going to do a demo right after this as well. So I think, Jim, you mentioned maybe help with support with that. So we can get that set up as well. Okay, we got a really good response here, 36 participants. So looks like most people use it as an alternative search engine. I know that's a pretty popular use of it right now, rather than using traditional Google. Some of it does already use AI for that searching as well. Lots of gloom and doom Skynet folks here, so the robots are taking over. So I get it, right? There's lots in the media, lots of unknowns. You know, it's something new, right? So, but it sounds like most of you are familiar with AI, working with it. So, and some super users here too, 1 out of 5. So that's great. Thank you. So we're just going to jump into a demo here. I'll just show it on the other screen here, and I'll just talk to you how we use AI to create some automation within AUD. All right, so you can see this is, we're using the latest AUD 9.1 and AutoCAD 2026. So throughout this year, we were looking to ways of how we could speed up our imported survey information. And so as mentioned, our current survey information is generally a CSV file. So I'm just going to go ahead and import that. So I have a CSV file here formatted. It's in a certain format with our points. It's got eastings, or latitude and longitude points on there, our elevations, and then our point description. Our point description is existing poles, new poles, ground profile, and any other important things like pipeline crossings and things of that nature. So I'm just going to go ahead and import that. You can see it brings in all the points, not really useful for us. And so we created a Lisp for us that runs several individual Lisps within it. But what it does is it analyzes all those points. It's going to turn it into an AUD surface. It's going to recognize those points that are poles and make them into AUD poles. It's going to connect those points together and create it into a line, and then connect that all up as pole heads. So I'm just going to run this. So if I zoom in, you can see it created the surface for me. It's starting to create some poles, some AUD features for me. And connecting that line, I do have a manual step here that I do have to click the conductor. Makes that into an AUD conductor as well. And now it's connecting all those poles together with the line. It's also doing the validation and resolve of what we currently have within our template. But obviously, once everything's up and running, it'll do the pole leveling, any calculations for integrity, and all the other stuff the AUD does. So within a span of less than a minute, I brought in my survey, and it's created that design for me. I'm just going to lift this off the ground because we don't have our pole leveling set in place yet here. But I'm just going to go ahead and lift the line up. So I'm just going to put all of mine currently at about 9.5 meters. So now we have an existing line set. We have the sag and everything in it. And if we want, we can also view it in 3D. So I'm just going to show this here. I do have a coordinate system I just have to assign. Right, so there you can see my AUD model. So I have my AUD surface. I can see my poles. I can see my sag, everything in there. And if I want to, I can zoom in. I can see where my pipeline crossings are, for example, and do additional analysis if I need to. So one other thing, if you might remember from our previous slide, our existing program called ALD that uses a side profile. So we were pretty excited to see the same kind of functionality within AUD. So I'm just going to run the AUD profile. I select my lines here. And it creates this nice profile for us. So I can see the sag in it, I can see the poles, I got my ground profile. It looks great. However, our existing tool, and just for adoption to have it kind of look similar, it does provide some additional information. And so we looked at that as well, using AI and coding to see if we could manipulate some of that same look and calculations on there. So we did create another Lisp. So what this one does is we're using Map 3D, so we don't have access to information in the background on this. So basically we take that AECC profile and explode it into its individual parts. What that does then is it creates from that boundary into individual line segments, and now it's going to connect them up into polylines. So this does run, it does take a little bit. I'm just running off a regular laptop, so it does take a little bit longer in regards to processing power. But what it's doing now is it's joining up all those lines. So for example, my line, my sag, into a polyline, and then it's going to split it up into individual spans. Once I have those individual spans, I can do these calculations now from different profile points. So here, for example, in each one of the points here, I have my clearance between the overhead sag of the wire and my ground profile, and indicating the minimal clearance between each of those spans. So all of these functions that we've had, big shout out to Matt and Graham and myself. The three of us were able to complete these, and all three of us have no coding experience previously. So this is all done using AI.
Okay, guys, this is our last slide. So this is just our future enhancement wish list, some of the conversations we're looking to have with other people this week. We mentioned the nonlinear calculations. Very curious to see if anyone else is going through the same struggle that we are, or if they have any ideas. And then just more workflows. We've shown some of the ones we've been working on. More out-of-the-box workflows would be something that we would like in future releases of AUD, I think.
Yeah, we're just struggling right now just with the different number of scenarios that we have with different wind loading areas, different scenarios for inter-circuit clearance, or our different seg calculations. And so just finding a way to streamline that so it's not processing everything all at once. Something that we're just currently looking at. Obviously, we know there's a solution, but if others have been before us and have some suggestions, definitely looking to have those conversations. Also mentioned before the conundrum of choice, right? So that best practice, what have others done? Template libraries as well, having that set up, and I think that's something on SBS's roadmap. And then the question blog. So I know the user portal does have a blog, hasn't been used in a few years, so I'm also guilty of that. But just to continue on conversations throughout the year if people have issues, to share that information between each other. So that'd be really appreciated. So with that, that concludes our presentation. Just thank you for your time, and yeah, if you have any questions. So we plan to have users start getting trained in it in late this year, early of next year. Our due drop date, I guess, of when we can't design how we're currently doing it is in mid-March. So that's when we're doing our Esri UN cutover. That means we lose access to our current design tool and GIS system. Yep. So lots of work yet to be done for sure. So. Say that again.
The question for us, do you have any pilot projects, like one or two projects that you know you can try this on and roll it out?
Yeah, and we've been doing that through our over-the-shoulder testing. I have a group of 5 or 6 guys from the design side that we're getting a new template every 2 weeks. We roll through the paces, do kind of your day-to-day stuff, and then make recommendations and changes. So yeah, it's an iterative process that we're going through for sure. So yeah.
For those that
Your question.
Yeah, sorry, for those that couldn't hear it, it was, do you have any pilot projects, right, that you're looking to do this on?
Apply AUD to before we try to roll it out.
Yeah.
Pat.
So the original Fortis, I don't need it. The original Fortis Alberta plan was to AUD UN. Then circumstances beyond our control, it was like, oops, no, we got to merge them together. How much conflict has that caused, or are you finding it better doing it? Because we've got half the customers here with that AUD, then UN on the GIS, and the other half doing together much elongated projects.
So because the people online can't hear it, so it was a timing question around your preference for AUD, UN ordering of that. Did I summer?
Yeah, they got forced into it
From an IT?
Yeah. So to summarize your question, Pat, whether to go with AUD first and then cut over to Esri UN, or vice versa. Now, we're obviously doing kind of both. We do want users in AUD prior to Esri UN. It does give us some benefits in regards to how Esri UN is getting set up. But it is going to be a huge change for us. So not only are the folks going to have a new design tool, but a new GIS system that's going to look different as well, right? And so that's one key component with us. We do have a team of the change management side for adoption, because that's really key, right? Is with these changes to support those, because it's going to look different, right? And so it is a challenge. I think you can fix anything with time and money, but you know, we're running out of time, and money is limited too, I guess, right? So yeah. So but it's something long coming, right? I mean, we left it to the end of when our existing GIS system was you know, getting outdated. We've never really had a live design tool or CAD tool, so it's been a long time coming. And so, you know, unfortunately, everything's happening all at once. But, you know, we're confident that, you know, at the end of the day, it's the right choice for us.